talks, I can hear Yaroslav. The class can hear Yaroslav.
Looks like no. We have one way translation.
Okay.
Юра, воно вже має бути трансляція.
Simplex.
Yeah.
They can answer your questions.
They can?
Yeah, I think yes. We can.
Oh, only by typing.
Yeah.
They can't speak.
Well, whatever.
Okay.
Юра, є. Кидайте їм, кидайте на каналі.
Можете доступити Ярославу?
О, власне, ставимо.
So you can test GS.
So how far have you guys read the book?
The book, I'm like.
We are doing the course.
Hmm?
We made like the lectures, the slides from the course.
On Interskill.
Okay, just the lectures?
Yeah. There are.
Okay. So which slides, like they're by chapter, correct, the slides?
I don't know. Roman said that in first chapter of the book there was like some additional information,
Mm-hmm.
but not a lot. Like there is much water in the book. Like
There's more to the book, yeah.
Because on the slides, like there is raw information.
Mm-hmm.
So just which we read and acronyms, functionality, and probably some comments on
Yeah.
the both. And in the book there is like they tell us about something.
More details.
Yeah, more details.
Hmm.
So,
There's like 17 chapters. So how many meetings will we have with this? How many meetings will we have?
Until it's enough.
Huh?
I'm not sure how many meetings we would need.
Oh, okay.
In fact, I just don't know. I was thinking about
Okay.
it, but
That's the only thing, my problem. I never taught this course.
okay.
And one of the things is, and also I never taught this type of class. My typical class was people with 5 to 10 years minimum experience. That, you know, it's okay, but so I'm just trying to figure out like the best I can have. Also, I'm speaking in English, and I've done that with other classes, you know, where their native language was not English. So you know, I have to slow down.
There are like 14 blocks of slides.
Oh, thank you.
We passed first.
You're doing, okay, that's the second chapter, right? 2.1? Is there another chapter before this?
No, only this.
And this follows the book?
I can ask Roman because only here is the book.
Okay. Because my slides kind of followed, I had like there was one set of slides per chapter. So maybe I'll just do that today.
yeah, it's almost ready. I'm
Oh, okay.
extracting it.
Oh, good.
Putting it there.
So let's open chapter 1. I'll do that. And chapter 1, or just not chapter 1, in the book, because I'll make sure I'm covering both from the table of contents and the book pages, and also make sure I adjust all the slides. Yeah, they vary in how much is needed. Good.
Book is here.
Oh, this is that.
Oh, okay.
That's the book you guys are reading, right?
Yes, slides are going with the book,
Yes.
like
Yeah.
the same information.
Yeah, kind of.
Here is the slides. Doing it as the
No, that's all well, bring up chapter 2 just in case they're like super advanced, and I don't want to be embarrassed by these guys.
we can open it later.
Yeah, oh, okay. Oh, you're gonna be here, right?
Yeah.
Oh, okay.
So here is the keyboard, mouse.
Good.
Юра, як там? Не скажеш на трансляцію?
Ні, деякі люди не могли юзнити навіть з посиланням в чаті.
Там бо я логав, це, я вже зараз не зможу поправити щось, якщо що. Так. Та як, Юрку покликати.
We start? Start now?
Це, це
Okay. This is-
Юра, translate us any questions people in the channel.
Okay.
Yeah.
Shit.
Okay.
So we can announce like that they can ask some questions in the chat.
Yes. If they don't ask, I will ask them, and they'll have to type all this down. So they have choices. They can type a lot, or they can ask questions. So, ask how many people have read the chapter, just to make chapter 1. We'll do chapter 1 today.
I lost. Okay. Mark. Let's talk.
Это просто пишу.
Андрей Гучев.
So the switch between,
Це
I see, there's the, I can figure this out here. Okay, so we can switch between that and the PowerPoint.
Of course, you can go full screen. It's,
Yeah, this is good for the call.
Юра, де кинули трансляцію, я не бачу.
Я
Я
всім
зараз
відписав.
вам
Я
кажу.
відписав всім в телеграмі просто. Бо мені ті, хто мене просив, я зараз.
Ким транслею зараз?
В загальний чи в новий?
Ні, цей наш.
Наш їх три.
Ну, наш цей. Це секунд. Ну, цей, що створений під
Це розумію.
наш workspace. So,
Get started? Okay. Can I just switch windows here? Okay, so, hello everyone. We have a couple students here and a number of you out there in the internet land. We're going to be talking about the mainframe, and what I'd like to do today is just start off with chapter 1. In chapter 1, we'll be talking both about what's in the book as well as what's in the slides. I think between the two of them, we'll cover a lot. My objective here is sort of like to get one concept I'd like to get across is when a computer is being built or designed, it's designed for specific customers, specific applications. And there's a lot of design decisions along the way of creating this computer. And they all have to do with meeting these customer needs. So that's sort of like what you'll be seeing me adding to this. I think chapter 1 is a little bit of, I'm going to say propaganda, why the mainframe's good and all that sort of thing. But we'll talk about other aspects of that you'll find in a normal commercial, either commercial application or a large government application. So let's get started here. First, I'm going to be switching back and forth between the slides and the text of the in the book. Well, of course, we show a picture right off the bat of the mainframe that's in a cabinet, and this is probably the only view any of you will get to see of a mainframe. You're typically not allowed in the room that this box is in. It's highly secured. It used to be in 1950s, 1960s, and even early 1970s, mainframes are always displayed. There were lots of lights, lots of little cabinets. When they had the tape drive systems, they had these tapes going back and forth, so a lot of movement. Then it dawned on organizations, hey, if something happens to this, we're out of business. So now generally, not only is the computer hidden and locked up, many times the actual data center is hidden. I had to teach once at a railroad company. They operated all the railroads in the eastern United States. And I couldn't find the data center. I'm supposed to show up and talk for a couple of weeks. Couldn't find the data center. I'm going back and forth. And sure enough, somebody came by and says, "You're looking for the data center, aren't you?" I go, "Yeah." "Oh, follow me." And we go through this little road, bunch of weeds, things like that. All of a sudden, there's this huge data center, and the building is the size of a couple aircraft hangars. Very, very large. So they usually hide this stuff. Nowadays, people aren't allowed in. Now, objectives, we'll be talking about how mainframes are used, how businesses and large organizations are using the mainframe, the types of workloads. There's a number of jobs associated with the mainframe. We'll talk about, look at what they suggest, and also have a number of other very interesting jobs associated with the mainframe not listed. There's 4 mainframe operating systems. Are they getting a copy of this on their, the students are viewing this?
Yeah.
Oh, good. We have a number of terms. Most of these, I think, you know. Application programmer, somebody that's writing code to serve an end user's needs. What's an architecture? Computer architecture, Roman?
Like the person that understands the whole idea of the project and
Okay, that's one. Is Roman out there?
Yeah.
What does Roman suggest?
they see it a bit later.
Like, yeah, it's like 10 seconds.
Oh, okay. I'll just talk to them instead of ask questions that way. Okay, an architecture typically is a combination of, there's a couple definitions. One is, it's a combination of hardware and software. So Intel 8086, something like that, 486, Windows. That's would be considered an architecture. That's one definition. For here, we have the Z machine in combination with ZOS. It would be a platform and architecture. Where is the architecture defined? Well, Intel has a chip. Its architecture is defined in its definition of the Intel chip. For IBM, there's a book called Z Architecture, Principles of Operation. In that, it describes all the registers, how big they are, how long they are, how they operate. It describes virtual memory, how it operates in the Z architecture. And for some of the programs, it describes every instruction in excruciating detail. So, architecture, you can look at, in terms of the Z system, it's defined in the principles of operation. I'll put I have this book on this. I'll give it out. Batch processing, business class, e-business. EBCDIC. There are several ways to encode characters. And what we do with Unix, typically, and with IBM PCs, is we use ASCII, A-S-C-I-I. There's an ASCII table. Here's the bit configurations. Here's the character. IBM mainframes use something called EBCDIC. We'll be looking later on at an EBCDIC table. Oh, environmental friendly, we'll be talking about this a little bit. One of the problems they have with mainframes is that they're very big and very heavy. So delivery of a mainframe is a very important operation and needs precise planning. Sometimes the mainframe cannot fit on the elevator. It's either too big or maybe too heavy. So I've been in places where from the outside, they lift the mainframe up with a forklift. And they even take out windows. Sometimes the bricks are on the windows to get that in. One of the things that the facilities manager has, in conjunction with the architect brought in, is to see if the floor can hold the mainframe. Because not only do you have this one mainframe box, there's a number of other boxes with the disk drives, peripheral devices. It's taking up the whole room, and that stuff's heavy. It's solid metal. The other thing along with that, the environmentals are very, very important nowadays. A couple reasons. One is space. So an enterprise company wants to expand its operations. It needs more computers. There may be no more room on the floor. They have to try to rent the floor below, the floor above, which may or may not become available. In some locations, for example, New York City, there is no more electricity. You cannot get enough electricity to run perhaps another mainframe. So they have those sort of problems. So environmentals are very, very important. So the power and the corollary to power is cooling. Mainframes just heat up a lot. That heat has to be dissipated, and it's dissipated with air conditioning. So you need, your power is not only to run the computer, and then to get rid of all that power that you've been using to run it. So environmentals become a big deal. High availability, we talked about that last time. People buy a mainframe for $5. They want that mainframe to be up 100% of the time. They guarantee 99.999. That equates to 5 minutes downtime a year. MIPS. This is referred to as million of instructions per second. It's also, we joke around in the industry, it's meaningless indicators of processing speed. MIPS, it's very difficult to compare two computers, two processors. You have to compare not only the instruction set, what particular instructions are doing, the addressing space of the computer. So there's a lot of things that go into actually computing the performance of a computer. But MIPS is used importantly for pricing the computer. Most businesses would like to buy computer power by the amount they use. If they start using more computer power, they'll pay IBM more. If they use less computing power, they'll pay IBM less. Now that's both for hardware and software. So MIPS is used by IBM in pricing out their software and hardware. Online processing, I think everybody's okay with that. typical as like an ATM situation. Platform, talked about. This infrastructure for the computer systems, there's a lot of money in it for companies. For example, a bank will typically have, as an indice, about 7% of their revenue will go into IT. So, as an example, you have Bank of America, very large banking company. They make about 90 billion per year. So that equates to over $7 billion per year in IT. So the IT infrastructure is very valuable and needs to be used as close to 100% as possible. In order to do that, people specialize. There's a specialty called production control. The person we call a production analyst, something like that, and their job is to keep feeding work to that computer so it is as close to 100% utilized as possible. Punch cards, I'm going to skip that. Well, I should say, IBM started off with, it was a tabulating company. It worked in, I believe, the 1890 census. In the United States, we take a census, we actually count people every 10 years. So it's every decade. 1890, IBM says, well, we could count people and we have a machine that can be used to count them. And it was, they were putting information not on tape, not on disk drives, they didn't have them at that time. They put all the information on cards, little paper cards, and they would punch holes in the cards, and those holes would sense, like the person's name, where they're located, information about the person. Well, it turns out that those cards have 80 columns. So we're going to see these 80 characters per record, and 80 character groupings come up quite a bit in our exploration of the Z system.
Yeah, I just interrupt.
Yeah.
Have you ever seen at least photo of punch card? Yeah, so you know what we are talking about.
Yeah.
Yeah. I think I got a couple at home. I have to find them. I didn't find them. There's a whole story, of course, about that. Reliability, accessibility, and serviceability. That's RAS. So now they've also added security because it's a hot item. Reliability, the R, RAS, the R, make sure that the computer is reliable and keeps working. Availability, similar to reliability. They're two are together. If they want that computer available, 5 nines. And serviceability means two things. One, that it can be repaired quickly. And second, also implied in this is that it can be expanded easily without downtime. So companies keep growing, their information processing needs keep growing, so they want to keep expanding the computer, and we'd like to expand the computer without downtime. And that's also the definition of scalability. Server farm, we're okay on that. I don't think there's any question on that. As we go through this hardware, we'll be talking about a little bit about the hardware of the Z system. It's going to have effectively what's called coprocessors. Now, in the old days with Intel chips, not even the old days, not that long ago, the Intel chips, we would have an additional processor with the Intel chip handling floating point. Here, IBM has additional processors that are specialized to do several, like one function. For example, It has its main processors, and then they'll have an additional processor to handle Java. It's handling Java virtual machine bytecode. It'll have a server, there'll be other ones we'll go across. Especially in system admins. In an IBM environment, they're generally called system programmers. So when you hear the word system programmers, it doesn't mean they're programming, it doesn't mean they work on systems, but they're more like system administrators nowadays. Now in the old days, the system programmers actually were programmers that made changes to the operating system. So as frequently we would patch the operating system. Now generally they don't do that. We'll talk about how the operating system is upgraded and maintained. TCO, total cost of ownership, and that's what IBM says. Somebody will say, well, I could buy this laptop or IBM PC for like $1,000. Why am I spending $1 million on the mainframe? And it's referred to as total cost of ownership. So let's see why that's lower in many cases with the mainframe. Transaction processing, the type of processing that is, there's two types of processing in mainframe. Mainframe people look at two types of processing. One is batch processing, and the other is transaction processing. Transaction processing, an example would be the ATM machine. You get on an ATM machine, and it's just going to process that one transaction. Airline reservation, somebody gets online, reserve a plane flight, transaction. Some things are done in batch. Typically, what would be done in batch? The payroll processing. It's going to be done all at once. So just one stream of updates of calculations and update to the payroll files, personnel files.
And just one remark. Those laptops, including mine, are direct ascendants of IBM PC. So I mean, when Jim says IBM PC, he means such computers.
Yeah. Oh,
They are not the ones that make
They made
10 years.
Okay.
So they are IBM PC compatible computers.
Mm-hmm.
They bring the architecture from middle of 80s.
This is, I consider this next overhead. What would you like, let's see, this chart. I sort of consider this a little bit of propaganda. I've worked with Fujitsu, I work with Sun and HPs, and they're able to do enterprise level processing, so I'm skipping over this. Next overhead, again, maybe a little more company-centric than I'd like to talk. Okay. Oh, a couple of things I should talk about this, though. One is IBM as a company. It's just a great company. Any of you that plan a career in IT, it would help to follow IBM. Follow what they keep saying is what they're going to be doing for the next 4 years, the next 10 years. That's usually, they seem to have a good way of forecasting technology. IBM has a number of Nobel and prize winners in science. They're one of the leading companies in terms of patents, issuing patents. Right now, they say their future is continue with mainframe, a blockchain, Internet of Things, cloud, and AI. So that's where they're going. I found them to be interesting watching and following. It's a good community with IBM. Working in this, there's lots of people online. It's like Linux. If you got a question, you could probably get an answer. They're one of the largest publishers in the world in terms of books. They have been and they continue to be. Oh my goodness, this next one. It's redefining the mainframe for 5 decades. And here we have all the acronyms you could possibly want. Well, in the 1960s, it first came out with their first IBM 360. What happened then? It was 1964. And what happened is they bet Watson, was the president of the company then, and he bet the company on coming out with this new computer. The new computer, of course, was the IBM System 360. The operating system wasn't called MVS, it was called OS 360. It was the largest piece of code written at that time, up to that time. What this was different is, they said, here is a number of models of computers. And every one will process a program, a program written for one of the models on any one of the other models. So what it meant is a company starting out to buy a small computer, gradually buy bigger computers, and all their software will run exactly the same way, because all of them had the same architecture. And that was brand new at that time. Before, it would be going like you have a program that works on Windows and you want to port it over to Ubuntu, have it work on Ubuntu. Big deal, it's like reprogramming. And that's the way things had to be done before that. So one of the things is a program that ran on this 360, any one of the models is good. What they've done since, all the way along through these years, is programs that were written 40 years ago still run on the Z system. So you're guaranteed that you don't have to, a company is guaranteed they don't have to rewrite programs because they're buying a new system. This shows a continuum of the operating systems from OS 360 on the left to ZOS on the right. The connectors, just a lot of acronyms. You'll be going through all these acronyms as we go along. But on the bottom, what I just want to point out is that the length kept increasing. The OS 360 was a 24-bit machine. That means the address space can be addressed by 24 bits.
Here is the question. How many memory can you address having
24 bits. Anyone out there in internet land can answer this.
In 40 seconds.
Obviously, we're going to ask you the other ones too. 24 bits, 31 bits, 64 bits.
So, do you have any idea?
Is anybody counting on their fingers? Okay. 2, 4, 8, 16, 32, 32. Oh.
If you have 1 bit, how many bytes can you address by it?
1 bit. 2?
0 and 1. If you have 1 bit, you can address 0 and 1.
You can discriminate between 1 byte and other byte. And if you have 2 bytes?
4.
Good. 3 bytes?
3 bytes. 8.
Yeah, 8. 0 through 7.
And then 24?
How about your colleagues out there in internet land? Are they just slumped over their keyboard right now?
We have almost a minute delay from the
Oh,
translation.
yeah. So that gives them some time.
A lot, like. I can figure it out.
You can convert it to megabytes. It's,
Okay.
You are not
How many-
obliged to use bytes.
So many bytes.
16 meg.
Yeah.
So, 24 bits is
16 megabytes.
16 megabytes. Then, around the early 80s, they came out with MVS extended architecture, and that allowed 31 bits. So that's an address space of 2 gigabytes. So they went from 24 bits, 16 megabytes of address space, 2 gigabytes, and now I don't know what this is. This would be like 2 gigabytes or 4 gigabytes times 4 gigabytes, 64 bits. Address space is important because that is a limitation to the size of your program and size of your program and data with our architecture we have. Some of these other words, I'll just mention the ones on the bottom. IMS is a hierarchical database manager. Hierarchical, it looks like a Linux directory structure. IMS. CICS is an online transaction processor.
Client.
Customer information and control system. It's a complicated bunch of software, and I noticed for the students for this university programs they have, they seem to be staying away from CICS. I think it's just too complicated to teach within a relatively short period of time for students. NCP is a network control program. This implements IBM's network architecture, SNA, System Network Architecture. WebSphere is a web server. That's what IBM calls it. WebSphere. Well, the languages they have on the bottom, assembler, certainly. COBOL. COBOL is a very easy language to pick up. Probably learn it in a solid weekend and do some decent job with it. It also implements C and C++, Java, and along with those languages. Okay, mainframes are hidden from the public eye. That's because it's a security risk in terms of a company. They don't want bad people getting hold of their computers. It's stable, reliable, dependable. There's lots of jobs, and we'll be talking about some of them. Even if you don't work with this IBM architecture, or don't even, if you don't even get into IT, this course will be valuable. You're not going to, there is no business that is nowadays existing that does not have IT. So even if you're the company president, you're going to be involved with IT. It has to be controlled. To control it, you have to understand it. Plus, it's just fun to learn about. Here we have a lot of text. What is a mainframe? I'll let you read this in the privacy of your own home.
We were talking about all this text last time.
Yes. Yeah.
And most of them do take several modules, so
Yeah, they wrote that some of our viewers like passed first block.
Yeah. I have to admit, I missed this one acronym. I looked up all of them and I missed this. So here, this has to do just with showing the capabilities of the IBM hardware and software, how they're expanding in terms of how much real memory. So this memory is in real memory. The number of CPUs, sort of like cores that you have in an Intel situation. Up above, the bandwidth, huge bandwidth, and that's the big advantage of the IBM systems. It's the input and output, huge amounts. And the last thing is ITRs, and I'm sorry, I didn't look it up. But it has to do with number of transactions that are processed. It's another one of the metrics IBM uses to price out software and hardware. So next class I'll have that. ITR, sorry.
Internal throughput rate.
What is it?
Internal throughput rate.
Internal throughput rate.
Yes.
Yes, we have to find out what is being, what are those? Are they like little gnomes that are running across the wire, or what are they? Okay, who uses mainframes? Probably 80–90% of the banks, financial institutions use mainframes. That's been my experience. Fortune 500 companies, largest companies are the largest companies in the US. 80% use mainframes.
I'm sorry, you have those slides?
Yeah, I just wanted to take the picture before this.
Oh, okay. Hi. It just stores a lot of stuff, but the biggest thing is input and output. There's a range of computers, and here on the left is a business class, enterprise class. So our view is just these pictures of boxes. We believe that inside of them, here's an example. You'd probably never see this. It'd be a rare time. You don't even want to, no one will even open up the doors to show you the inside of a mainframe, because you're altering the airflow. So this is usually a student's view of the mainframe. If you work as a programmer analyst, it's a good chance you'll never see this. You can work like 10, 20 years and not see the mainframe. So it's interesting. It's got stuff in it. All this we talked about, I think. We have two types of workloads in an IBM shop: batch and transaction processing. What we get out of this is, I don't like this too much, this particular overhead. Typical batch processing, the way to look at it, typically there's the transaction file, there's the master file. So let's say these were payroll updates, the old payroll file, update the master file with an update program, create a new master file. So you end up with the new one and the file. So typical batch processing. Transaction processing, whoop, I keep bringing up ATM, it's like a good example. They had a number of transactions. This just shows you, this next overhead is typical batch usages. Typical, I have like payroll. The accounting people love batch processing. So the computer tends to be very, very busy at the last week of the month. Almost all companies, I'm going to say, they want their month-ending reports the first of the next month. That's typically batch processing. We have some people that are involved in this. Production control, the system operator, usually in flip-flops and long hair like this. Disk storage is, unlike your PC, storage is always external on mainframes. And they're going to be connected. The storage frames are going to be connected with fiber optic cable. We'll talk about what that looks like. What else was this? Common also with mainframes is tape storage for long-term storage. Government, the U.S. government, almost everything dealing with accounting, taxes, and so forth requires 7+ years of retention. So these historic files typically, instead of just keep them revolving around expensive disks, they will copy those files to tapes and store the tapes. These tapes, nowadays, they handle about 5-8 terabytes each tape cartridge. There's a number of folks that are working on this. Here's our business analysts. Here's somebody worrying about inventory control. There's a continuum, as I mentioned last week, or last Monday, between users and the people working on the operating system. And over on the user end, there's a user, and the next one over is typically a business analyst. The business analyst works for the IT department. They understand the capabilities of the infrastructure that the business has, and they try to convert the user's needs to program specifications.
Does salary also increases from business analyst to ZOS program?
Yeah, in a large, I'm sorry, in a, just say it again.
Like, does salary also increase from business analyst to ZOS program?
No, okay. Let's talk about how people get paid. That's not a bad thing to talk about here, because I don't know if there's another class that does this. Okay, how do people get paid? Well, it has to do with, one is, for this particular job, what skills are necessary? How difficult are they to acquire? How many people have these skills? Usually related to how difficult it is. The second criteria for how much you make in a job is responsibility. If you're operating this computer and you press the wrong key, how much will it cost the company? Or how big of a problem will it be? If you're operating a PC for a grocery store, a food store, probably not a big deal, right? You just correct it, you go on. On some of these jobs, you press the wrong button and all the trains stop on the east coast of the US. If somebody is near that key, they make more money. An example, I'll give you another example of this. You know, sort of like one job I have quite a bit of associated with this. Our power companies that use nuclear power companies, electric power companies, they typically have very high-paid operators who just sit there, and it's one of the dullest jobs in the world. But they pay them a lot of money. Why? Well, skill and responsibility. They make a mistake, and from around here, you know what could happen. The third factor in how much you get paid has to do with just plain money. Okay. So that's why salesmen tend to make a lot of money in large organizations. If you're selling this machinery, if you're a salesman, they call them account executives at IBM, you're making several $100,000, up to $1 million. Because you can bring in a lot of money. Remember we talked about Bank of America, $90 million revenue, $90 billion revenue company. IT expenses typically would be something like $7 billion. A salesman capturing part of that money is going to get well compensated.
And just comment the background of this question. There was
Yeah.
one gentleman from computer science and one lady from business analytics. So there was some competition on the disciplines.
It depends what you're going to do. If you're running this little program that's making just ad hoc reports, not too much. If the business analytics person finds a way for the company to save a couple million a year, you'll do pretty well.
Because as the programmers, we take skill responsibility as a main.
Yes.
We can.
Okay, skills are good. Responsibility, not all the time with programming.
No,
I'll give you an example.
It depends on the place that it's in the company.
Pardon?
It's dependent on the place in company.
Exactly, but you can, there are some functions which are absolutely, you cannot, errors become big deals.
No, I just talking about IBM because if you're near the, like, if you're a ZOS programmer, you have a big responsibility for the IBM mainframe.
Yes. It depends what the function is. In some areas, it's more important than others. For example, I was responsible for a bunch of, it's a better way to say it, a bunch of financial systems for a few companies. The most critical application I had was not production, it wasn't sales, it was payroll. Make a mistake on payroll, and some guy on the shop floor, he can't read, he can't write, but he knows exactly to the cent of what that paycheck's supposed to be. You guys got it? And you end up with situations like that. Yeah, so, I don't know if I'm answering, did I answer your question? Good?
Yeah.
Anybody else out there in internet land that has a question, comments?
There was a question about previous lecture about
Okay.
how the channel in mainframe is so fast because you compare it to SATA.
Yes, I can't do that. I don't think I can get to it today, but I will. There's a couple things I will go over a number of times. My approach to teaching, this is kind of simple to go through once. There's a number of things I'll go through several times. How I/O works, which includes the channel. Just what is it doing? How does it work? We'll do that several times. Virtual memory, you're going to know that cold. I did a little bit of it last Monday. I got glassy-eyed, everybody staring and nodding and smiling. But I'll go over this more. Okay, so that's another area that I want to make sure everybody gets. Is that, to relay it to your colleague there. He'll know this in excruciating details. There's other work also here. We'll be talking about a number of systems in a mainframe shop. And every one of them needs a very skilled technician to run and understand. The examples, the security system. In IBM it's called RACF. Another acronym, we'll get to it. The data communication, just the software on the mainframe, needs a specialist. Performance is a big deal with the mainframe. So you want to make money? Start thinking about skill, responsibility, and money for somebody who can get 3% more out of a computer. Remember? That's $6-7 billion. 1% is big money. Does everybody follow? So performance is a big deal. The other thing is somebody who can diagnose and fix things quickly. I know I've taught a lot of programmers, and the first thing I start looking for is, can they find and fix mistakes?
Very quickly.
Yes. If the system's down and somebody wants something running, and in the morning, the reports or the transactions have to be finished.
But it also depends on the place in the company, yes? Because
No, all places want perform, I should have said no like that.
No.
All places want performance. That means they don't have to spend more money to expand the machinery or is it as fast.
understood, so all
Yeah.
programmers must find the mistake very quickly.
Yes, and if you're a programmer, you have to it's called debugging. You have to be good at debugging. I look for that right away. If the person can't debug, I don't care if it's a program or RACF or some of the other software we're going to be talking about. There's going to be problems, they have to find them, get them fixed, get things going right away. Okay? So it takes sort of a logical mind, but before the logical mind.
Like a main skill.
Yes. So the main skill is you have to know your software code. And second, be able to find, when something goes wrong, be able to find it and fix it. That's basically what you're getting paid for. But one of the disadvantages of a career in mainframes is most of the jobs, you're on call. If your system is bad, you just don't go, I'm taking the kids to Disneyland. You come in and you stay there until it's done. One of the disadvantages. Now, business analysts usually have less requirement for that. So the more you go over toward the, remember we had this thing, user on one end, on the other end we have system programmer. The more you go over to that system programmer specialty, the more you're on call, like it's got to get fixed. So this is like Silicon Valley, they have that culture of signing on. It's not like, well, I'll get to this new product you know, after I come back from the beach. No, you just stay there, you work until it's done. So, mention that. So these are the type of jobs. There's also, you're very valuable if you know a lot about the mainframe, if you work for not Sun Systems nowadays, but Oracle. Oracle needs people that understand the competition. Does everybody follow that? I had a job, one of the jobs I had at last place was solutions architect. It's kind of a funny sort of name for a title, but basically I was the salesman's happy helper. The salesman was responsible for personal relationships. He talked to the CEO, the CIO, the chief financial officer. He was like friends, they go golfing. He talks to them. I was responsible for the technical relationships. So I talked to the system programmers. They would ask questions like, Sun does it this way, how does Ambo do it? And so I had to know both my equipment, software, as well as the competitions. Those are kind of fun. That was a fun job, I liked that. So there's lots of roles. They all look very happy. Nobody looks like they're sweating, like things aren't going right, and that's why they're there. But that's, I always, my friends who've been in this business for a while, we always joke about end users. End users lie. Now, I'm saying they lie as like not even telling the truth, but they don't mean to, but they just do. I remember on a payroll system, there's a lot of what if. So the payroll system is connected to the personnel system. Personnel system has all the people. So we have the case of an employee, somebody who just got hired, somebody who just left, somebody who was rehired. So you're talking to the end user. This guy's in charge of the personnel system. He's the user. He uses the system. So I go through all these kind of, or I did, my fellow work for me did. So Terry goes up, he goes through all this, he writes a memo, and the guy says, yes, those are all the possible cases. Until all of a sudden, we run the program for testing, the program doesn't complete, one of the records, it can't handle one of the records. There was somebody that retired, went on pension, and got rehired. Like, they just didn't have those situations covered. So we always joked about what all meant.
System administrator on this slide looks pretty tired.
Yeah, oh, he looks tired, yes. Yeah, operator, that's the guy who's like you're on a PC turning it on. You don't get to touch the keyboard. You don't get to turn on and turn off the machine. There's a specialist doing that. So the specialist thing is plus and minus. On your PC, you got Linux, and you can run everything. You can install new things, play around with them, configure them. You can do all that to all the software in your machine, your PC. One of the things in a large shop, you're going to be very specialized in a small area. It will be up to you to constantly study and try to look and learn the other areas. If you don't, you'll eventually lose your job. Not this year, not next year, but 10, 15 years from then, you're going to get behind. The other thing is, this machine is so expensive, the whole system, the whole infrastructure, is they're constantly trying to automate the functions. Not because people aren't worth it, just the automation, a lot of times, just does a better job for most of the things. So there's a constant push to reduce the number of people working on some of these functions. Storage administration is an example. The people managing the disks. It used to be one guy would worry about tapes and the files, things like that. Now, one person can manage a huge network of storage devices. If you keep the job in that area, you're making more money. Skill, responsibility. There's a lot of operating systems that this guy runs. This is a history, but concentrate, this is mainframe operating system heritage. Kind of just, we're going to be talking about ZOS, that's what we're here for. IBM has some smaller machines using the same architecture. And they're using sort of a dumbed down version of ZOS. And that's called VSE.
For smaller devices? Or
Yeah, yeah, they just don't need all these facilities for a smaller business. Like you would not run ZOS on a laptop. You just don't need all that. You don't need all the security, you don't need the complexity of the I/O, things like that. Did you follow? So a smaller company just doesn't need all these facilities, and they may not have the personnel who specialize in each one of these complicated pieces of software. TPF is still being used by airlines, credit card banking. I just actually only was at one operation that used TPF. So just, you know it's there. ZVM is a virtual machine, and that's used for the level 2, type 2 hypervisor. You guys, type 1, type 2 hypervisor?
I don't know.
Okay. Can they see what I write?
Yep.
On the camera? Or like, we can see, but the no, it's like it's.
Let me try to. I'll draw it here, but I'll try to be explain it. I draw on the bottom is on the bottom I drew Z system, so that's the hardware. On top of that, I could draw ZVM. On top of ZVM, and on top of that, I got a couple ZOSs and a Linux. So here, ZVM is a there's like a hypervisor and OS, sort of like a combination.
And what is the difference between the types?
Okay. There's another type. So this is a type 2. Type 2 hypervisor, so the hypervisor code is like here. Another type would be a type 1, would be like LPARs. Z system. So some hypervisors run on bare metal, as they say. For example, VMware has two types of hypervisor. Well, one will run on either Linux or Windows. So that would be a type 2. They also have another VMware that you install on an empty PC, type 1. So a hypervisor that installs directly on the hardware is called a type 1. A hypervisor that installs on an operating system is a type 2. A type 2 virtual environment have a type 2 has a host operating system and guest operating systems. A type 1 doesn't. Type 1 does not have a host OS. Did I explain this? Yeah. Guys okay? Good?
Yes.
Okay, the next one, summary, is good. Okay. I was doing time-wise, I'm keeping track of this. What you guys want to do is fine.
1 hour, 50 minutes.
We can go. How long do you expect to go?
As you want.
Oh, I can go for 1 or 2 days probably.
Yes.
We'll take food breaks.
Okay.
We'll bring pizza in. Okay, and I think is the last for this intro deal. I don't want to talk too much. Is done with this? Okay, I'm going, sort of, let's see, where is, which one is the disk drive? It's coming up. I'm trying to look for the other, I'm just pausing just for maybe 2 minutes.
Google Chrome there.
Chapter 2.
Oh, here, this is what I want. Wait. So we're going to talk about hardware systems and LPARs. This is the second, let's stick with this thing. So we're going to talk about the hardware design. It's already starting to be more interesting. The other one was a little propaganda stuff. Mainframe terminology, there's a lot of it. We'll talk a little bit about the hardware components. It's kind of interesting to learn about them. Okay. Mainframes and PCs differ with coding, and the main difference is that EBCDIC and ASCII PCs that you're using use almost all the characters are in ASCII format, or in the mainframe they're EBCDIC. There's a lot of terminology. Oh. So I'm on the one with terminology overlap, and I actually had to go to my notes for one of these things. What is the system called? A box, a CPU, a machine, processor, the whole list of things over there. And the one I had trouble with was CE. I think I wrote it down. CEC, and that stands for Computer Enterprise Complex. Who would have guessed? But those are kind of three good words. Computers, everybody likes. Enterprise sounds like a big deal. So you're gonna pay more money for something that says enterprise than just machine. And complex, again, you're not buying a small thing, you're buying something that's worth a lot of money. So you're paying more for it. Okay, so let's see. LPAR is frequently referred to as image. Maybe somebody calls it server. So there's a rich variety of acronyms that we'll be seeing with this. The 360, next one, early system design. What's happened is everything got to be more. In the early 60s, it had only 16 channels. A channel is a connection to the outside world. So, right, what IBM did, maybe I'll be able to do this later. But basically, I'll cover this later when I have overhead. Channels connect to control units. Now, control units are frequently abbreviated CU, or control unit. The way IBM did things is it would have some type of peripheral device. Peripheral devices are terminals, disks, printers, things like that. And what it typically would do is the channel is a connection attached to the mainframe, the big box. There's a wire going from that channel to a control unit. The control unit would have most of the electronics for a group of peripherals. For example, what I came in here today with was a disk drive taken out of a laptop. Now, what's in here? There's little disks covered with magnetism, spinning around, and there's a lot of electronics. Like this back, the green part of this disk drive is a circuit board, and there's electronics on this. What IBM did, instead of having all the electronics on every one of the disk drives, instead has one box with the electronics and just a minimal amount of electronics in each one of the drives. Follow? Okay. It's just more economical to do that. And at that time, it was a big difference in the expenses to only centralize the electronics for a group of disk drives or a group of terminals. So we had a control unit for terminals, we had a control unit for disk drives, control unit for printers, things like that. A channel ultimately has access to the memory of the mainframe. So when a computer wants to write a record to a disk, what happens? It has to take the program, computes or creates a record, puts that record into main memory, and then tells the channel system, hey, take this and deliver it to a disk drive. The channel then goes into memory, goes to that buffer containing the record, moves the record over to a control unit, to a disk drive. Questions? I should go over that again?
If you can,
Okay.
it would be great.
So, how does your program creates a record that it wants to write to disk? Sort of high level, we'll get more details later. So the program does what? It has a buffer, the buffer exists in main memory. The main memory is connected to the CPU. The record is now placed in main memory. The computer then says, hey channel, take this stuff in memory and send it to this disk, my disk, which contains my file. The CPU now is done with the I/O, because it's all going to be handled by the channel. The computer now can go on to do some other work, the CPU. In the meantime, the channel is going to do what? Go into the main memory, pick that record up,
And put it to the
go to the control unit. The control unit's going to give it to the disk drive. The disk drive is going to change the magnetism on one of the platters. Is that an enlightened look or a what just happened look? How are we doing? Good?
answer.
If it's not, because you've got to explain it to your baby sister when you get home.
And good practice.
The smart one in the family.
Yeah. It's like
The smart baby sister, I should say it that way. The smart baby
my
sister.
brother.
Very smart, actually.
Okay, good.
My brother always asks what I have done in the university, and then tell me, please, tell me.
After you talk and tell him this, I think he will be curious.
Okay, it'll be a future programmer. Okay, so again, I/O does what? A program creates a record. The record is physically in main memory. So your program wrote this stuff into main memory. Then your program says, hey, take this stuff and write it out to a file. How that's handled in the mainframe is the CPU tells the channel program, hey, take this data, it's in this place in main memory, shove it out a wire, the control unit's going to get it, the control unit's going to give it to one of the disk drives that's hooked to the control unit and writes it on the magnetism. Good? We'll fill in more details later. These devices all have numbers. And in this overhead says device address. In this case, the address is 123. The 1, the 2, and 3 are hexadecimal numbers. They're not human. So FEA is a valid address. Is everybody okay with hex? Did you have hexadecimal yet?
I will translate to Ukrainian.
They should know about hex numbers.
No,
Uh-oh.
not yet.
Okay. Eventually, you have to be able to translate from human, 1, 2, 3, 4, 5, 6, if it's 0 through 9, you have to be able to translate from that to hexadecimal. Humans have how many fingers? 10. 10 digits. And the digits are symbols 0 through 9. Remember, computers always start counting from 0. Now, the computer uses binary, that's all. But there's a shorthand way, a compressed way of showing binary numbers. Hex. Hex digits are 0, 1, 3, 5, 6, 7, 8, 9, A, B, C, D, E, F. There's 16 numbers in the hexadecimal system. The reason they use hexadecimal is because each hex number is 4 binary bits. So hexadecimal is for humans, not for computers. But it's a shorthand way of seeing what's going on in the computer. You'll need to be able to do addition and subtraction in hex. That's part of life in this business. So I can give them a problem for later on. So we have to add, not now, later on, in the privacy of your own home, you have to add cafe, add babe to cafe, and get an answer. We have to add and subtract by hand, not with the hexadecimal calculator, because that's like not very skilled. Okay. So you have to be able to do binary arithmetic, but hex arithmetic, not multiplication, not division, but adding and subtracting. You just do it a lot. You need it in programming. There's a number of exercises, I think, in this series that require you to do that. So it's just life.
They should know the hexadecimal arithmetic.
Yeah, I saw it like the eyes going, oh no, not that again.
No, we were working with decimal, like.
With human.
Yeah.
Yeah, so you can't.
You had discrete mathematics?
Yes, with decimal numbers. We were.
Okay, we're going to cure you of this human frailties. We're going to use hex. So anyway, these addresses of these control units and channels are in hexadecimal digits. So you'll see characters from 0 through F. That.
What's the problem?
Okay, parallel channel connectivity. I don't know why they even put this here for university students. Years ago, the connectivity between the mainframe and control units was in copper cables. Cables that had copper wire in them. And those cables were I'd say a couple centimeters in thickness.
Like these cables for channels, yes.
Yeah, so they call these bus and tag. On this illustration, you see the bus and tag cables?
Yeah.
So those had a fairly limited distance. And nowadays, it's all done with fiber optic cables.
That's why they are so fast.
But just little stories. It used to be these mainframes sat on a floor, of course. The floor was maybe sometimes up to a meter high off the concrete. So in between that, below the floor was a big empty space, and it was for these bus and tag cables. In some places, that was completely filled with cables. They couldn't install any more cables. Fill that whole space up under the floor. Nowadays, they're using fiber optic cable, and instead of under the floor, there's an opening on top of these cabinets where the cable comes in. The protocol nowadays is either something called SCON or FICON. So the protocols on these, on the new fiber optic cables. Nowadays they use fiber optic cables instead of parallel, and the fiber optic uses SCON or FICON as the protocol to move the data back and forth. FICON or SCON would be similar to Ethernet for your machine when they're physically wired to the router. System 390. Yeah. With this next one, Conceptual System 390. Conceptual System 360. With this you show. The only thing here I would like to show you is notice that on top is the channel. The channel goes to a control unit. Off that control unit, each control unit is controlling, in this case, a number of disks. Okay, I skipped over one. I'm at two models for system Z10, and I noticed there's a model 2098 and a 2097. It's showing the physical size, and as I said before, these environmentals, like the size, is a very big deal. The size, the weight, and power consumption. Power consumption in two ways: the power to the electricity to run the CPU. And second, the electricity needed to cool the CPU. This is the next overhead innovative designs. Shows that things are all connected. Lots of parts in a box. This is, just to be honest with you, this is an area I've hardly ever come across in these decades of working with these machines. This is hardware. I almost never got involved in the mainframe hardware. The only people touching this generally are the CEs. CE stands for Consumer Engineers. These are people employed by IBM, and in large shops with this kind of enterprise class machines, IBM has full-time people at that company. And they're the only ones touching these, physically touching these machines.
And they're working 5 minutes per year?
Pardon?
They're working 5 minutes per year?
Yeah. Yeah, they're there to install things. For example, these machines do what's called call home. If a part in the machine starts going bad, it creates a phone call to IBM headquarters, and IBM, the guys on site get the message, and IBM headquarters gets the message. A very important thing that you get from, I should mention about this with IBM. It's kind of a good company, and it's a good model for how businesses deal with businesses. So let's take a look at what's going on. One, IBM always had a history of, if you bought IBM equipment, IBM will take care of you. You will not be sorry that you bought IBM equipment. If something goes wrong, IBM has a very quick response and problem escalation. What's problem escalation? It gets a message saying a disk drive is going bad on one of the drives. Gets a message, the first thing, the C goes and replaces the disk drive. Physical replacement. It may be a piece of software all of a sudden is giving strange responses. It goes to the first level. They have maybe 15 minutes to start to fix it. If they can't fix that one problem in this one piece of software, it starts getting escalated through IBM. Eventually, the guy that wrote the program is going to get on an airplane and get over to this company and fix it. IBM takes care of their customers. And this process is called escalation, problem escalation. Usually, typically after 1 day, at most 2 days, then the top expert in the company on that area of problem is flown in. So IBM does take care of their customers. When IBM gives a presentation, we always joke, it's in the movies, like, especially the old movies, Cecil B. DeMille, like Cleopatra, he must have 5,000 extras to make that movie. So we always call that cast of thousands, the movie cast of thousands. And IBM tended on marketing presentations to have a cast of thousands. They're going to give a presentation on how the system works, and you end up with a big conference table, 15 people from IBM come in. IBM's doing what? You're not buying the salesman, you're buying all these people. And each one of these people are introduced as a specialist in some area. And they know everything about what they're supposed to know. We have another one, current internal componentry. Again, this is kind of interesting. I don't know many people in shops that even know this. This is not a popular area because you can't do anything about this. Recent configurations. This is a good one. We're going to get more and more detailed on these pictures as we go along. In this one, we're getting a little more detail. They're showing some channels. Here the channels are hex 01, 02, hex A0, hex A1. So these channels have hexadecimal numbers on them. The channels usually nowadays are not directly connected. They're usually connected, if it's an SCON channel, then it's connected to a SCON director. A director is just another name for a router. So this is just like an IP router, has that same function. Fairly a link layer communication. And in this case, we see the SCON director. It's hooked up to channels hex 40, 41, 42, and it's connected to controllers C0 and C1. Notice that C0 is a disk controller, C1 is a tape controller. We talked about controllers generally have most of the electronics needed by a string of devices. In this case, channels A0 and A1 have another type of protocol, connectivity protocol, called FICON. In this case, it's for fiber optic cabling, and A0 and A1 are connected to control units.
C1, C2.
Yeah, thank you. C1 and C2. SCON and FICON are competitive, so to speak, protocols, and FICON won. So, yeah, I'll just mention that. What's important in our business, and just in engineering, electronics, as a matter of fact, all kinds of areas, is standards. Hardware, in order, somebody can invent something. For example, they invented fiber optics. We can send light, it won't escape through this little glass fibers. Can it be used? No. It's not going to be used until there's standards of how to connect this fiber cable to devices. So they eventually, let's take Ethernet. You got Ethernet. The wires are standard, so many wires per cable. The connector on your Ethernet is standard. The male part, the female part, they connect together. So once standards are established, the new technology can be utilized, distributed. Setting standards is a combination of several things. One is, of course, technical, but the best technical solution doesn't always win out. In addition, it's economic and even political. So you'll see new standards come out, and they're usually the result of technical, political, and economic dynamics. Examples, are you guys old enough for Beta and VHS? Does that sound familiar? Oh, no.
I know, of course, I know about the story, the technology, but they definitely.
Okay, they don't.
For what we need to switches for channels?
Okay, the reason you need switches is for availability. What this does not show, let's go on the right. We have A0 and A1 channels connected to a FICON director or switch. The FICON switch is connected to a couple disk drives. Most important in an enterprise operation, mainframe environment, we have to eliminate single points of failure. What if this FICON switch loses power? The power supply goes bad. What's going to happen in this case?
An hour switch.
We just lost this data. Is everybody following this?
Yeah.
Is you have data on these barrels on the bottom. The disk drive's connected to C1 and C2. If that switch goes bad, FICON switch goes bad, you just lost your data. Some lady can't get to the ATM machine because her account information is on this disk drive all the way on the right one. So what would we do? We would have a second FICON switch. It would look A0 and A1 would go to the second FICON switch. That FICON switch would be connected to both C1 and C2. So concepts, single point of failure is the biggest deal. Does everybody follow that? So in an enterprise environment, you're constantly thinking, what happens if this goes bad? What's the backup? And the backup isn't, I'll reboot my computer. It has to automatically keep going. So there's redundancy throughout the whole system. And the disk drives I worked with, let's go look at these disk drives, that 0 and 1. The disk drives I worked with, each disk drive had 2 connectors, 2 fiber optic connectors on the disk drive.
One for the backup.
Just in case, just to eliminate single point of failure. They were not only in RAID 5, they were in RAID 6. We'll talk about that later. So if a disk went bad, there'd be a backup. If another disk from the same group went bad, there'd still be a backup. So I could have a group of disks with 2 drives going back, and the system keep working. So this is one of the biggest things you get in an enterprise is not only the physical thing, but it's an attitude of the people. Is that this place has to keep working. This isn't like, I don't care, we'll fix it later, we'll reboot. You just cannot do that in an enterprise. You lose your job. You're making lots of money, skill, responsibility, money. But this responsibility means you can't let things go bad. You do whatever it takes, and you keep planning ahead of time how are we going to prevent loss, downtime. It's like a different attitude that you'd find in an engineering shop. You know, the workstation goes bad, you got to fix it. In the meantime, you do calculations on paper. In enterprise, you can't. You just got to keep going. Some of these things, I think I mentioned it the very first talk I gave you guys, and it's these Toronto Dominion guys mentioned at one time that part of their network way out north in Canada broke. And some senior citizen lady goes to the drugstore and wants to use the ATM machine to get money to pay for her prescription medicine. The ATM machine was down. She didn't get the medicine. Her condition got worse. You could see Toronto's Dominion's name in the newspaper. See the problem? They start off, you've got a networking problem, all of a sudden you're in a newspaper and it's not a positive article. Little old lady gets a death deal because TD can't keep their network up. That's what the world is like out there.
Yes, there is high contrast to things you mostly do here in some projects. Because if you have some private you have some train traffic, you have Facebook, you expect those services to work constantly, all the time. It's examples of enterprise services.
Yes.
It's a little bit unusual for experience of students to set such tasks.
I know, that's why I'll be going over this several times. I know it's just a different way of looking at things, but that's why you make the big money working with big hardware. I have another story also. This is at the railroad company operating these railroad things. The mainframe is connected to these switches, similar to this. You got the mainframe, you've got these FICON switches, and then you've got these disks. And one person on his own wanted to attach another disk drive to a switch. They just got some cable, plugged it in, but the person did not go through all the authorization and checking procedures. So the person got 2 weeks off. No pay. Next time, no job. So you can make big money, but nobody's gonna hire that person again if you lost his job just because he doesn't care about the responsibility of the person. It was a he at third. Okay. So it's just a different attitude. Also, when you hire, I shouldn't have you, when I hire people in these situations, I'm looking for a sense of responsibility. Like, this is serious business. It has to work all the time. Just sort of an attitude. Any comments from our viewing audience out there? They're all probably sleeping, eating dinner.
Jim,
How are we doing on time?
I think it's maybe
Good.
enough for one day.
Oh, yeah.
It's
Okay,
almost 2 hours, and as my practice shows, they are starting
Oh,
losing
it's burning out.
concentration.
Okay, yes. Okay, thank you. If you have questions, I'll be online.
Maybe you or
Comments?
anyone from online have questions on the course they have read, go through or whatever.
I also announced one question about channels, but Jim already asked.
All will, it's just tell a person, all will be revealed about channels.
I will ask Roman.
Yeah.
I have, if you will have time,
Yeah.
we can visit our supercomputer,
Uh-huh. Oh,
our supercomputer institution.
yeah.
You've been here, so,
Yeah.
but if you want, you can go once more, it's not a problem.
Good.
So after we end this question and we arrange our next meeting place, and we can visit Institute for Condensed Matter Physics, and then we can hear.
How is this useful for you guys?
very useful. No one has any question.
They're all sleeping, I can tell. I'm gonna get some kind of, they're gonna be on the internet themselves. I don't believe this. They're all slumped over, they're rested now.
So, when we can meet next time?
On Friday?
Yeah, would be great.
Friday we have celebration of our Independence Day.
Ah,
It's not a
Oh,
problem for me, for
holiday!
example.
Who would have thought there was a holiday?
No, it's not a problem to come here. It's I will be in view, but Jim may be with some.
Whatever you guys want to do.
I even didn't know about it, so I can come.
So, we'll send on it and arrange meeting online.
Okay.
Jim, Friday would be okay for you.
Yeah, whatever you guys want.
For me, all the time is okay.
Same.
Think it's not the. I think that it's one of the best way to celebrate independence of Ukraine. That to work hard.
Yeah, it's like Labor Day in the US. We get off, and I don't understand it, we ought to work.